name is Ekaterina Tzekova. I'm doing my PhD with Professor Kim Pressnail in the Civil Engineering Department. I've been involved with 31 Sussex since the beginning, since essentially the design phase. And I'm also involved in construction, so from the university side, from essentially the designer side, myself and Professor Kim Pressnail and Russell Richmond from Ryerson University, they're sort of the co-founders of this neat concept called the Gemini nested thermal envelope design that we're implementing in this house while we're retrofitting it. And my involvement is essentially, attending meetings, coming on site, looking at problems, making sure that, we're building what the design intent is. We're standing right at 31 Sussex Avenue. This is a house built in 1879, historic house that is currently owned by the University of Toronto, and we're doing a really neat project where we're essentially gutting the house, where we're retrofitting it completely, with the exception, of course, of the beautiful facade. And we're actually implementing a design concept we refer to the Gemini nested thermal envelope design. So essentially we're creating a building within a building in this historic house. There's a lot of different stakeholders in this particular project, and there's a lot of manufacturers as well as consulting firms that have donated in time or services. So there's a couple of neat ways we're using some of their products. For example, with a heat pump, the outdoor unit is typically outdoors, but we're using it in an interior space. So that's kind of a neat application for them. So they would definitely be interested to see how it functions in this type of environment. Generally, our goal is to show that if we can make the Gemini design work in a historic existing home where you have so many more challenges than a new construction, for example, if it works here, then it could really work everywhere. We've done some preliminary order of magnitude calculations where we're looking to retrofit a house. And we've achieved an order of 70% reduction of a typical house. So constructionally geared up over the last 2 months. We started essentially from the ground up, from the basement, working our way up. So a lot of the structural modifications have been done. There haven't been a lot of complicated things happening, just beefing up some of the things because we've taken partition walls or we've moved them. We've also looked at, we've casted a new slab in the basement. We've also insulated underneath that, provided proper drainage. The framing is starting to go up on the first and second floor, that we'll sort of shortly see. And the next stages will be starting to insulate, build up our walls, etc. So we're installing a couple of different sensors within the walls, the regular temperature and relative humidity between different material interfaces. So very briefly, the walls, you have your exterior masonry, then you're going to have insulation. Then we're going to have these cool, almost metal ducts. They look like metal ducts within the walls, and that way we're creating a perimeter airspace. So we're going to be drilling holes in the brick, and we're going to be supplying this sort of filter mesh fabric right against the brick. And that's going to serve as a vented airspace that's going to be open to outside air, where we hope air will come in, circulate, help pick up moisture from the brick, and exit. I think my favorite aspect of the research is really trying to tie the low energy component with the historic aspect, because we're trying to create a low energy house by any standard. But at the same time, we have to be mindful of the historic aspect of this house.